Okay, so now we're going to take a look at solving equations quadratic in form. But let's review on how to solve a easy quadratic equation first. We've got x squared minus 8x equals negative 12. Again, I want to set it equal to 0, so I'm going to add 12 to both sides. So now you ask yourself, what factors of 12 add up to be negative 8? And that's negative 6 and negative 2. Because negative 6 times negative 2 is positive 12, and negative 6 plus a negative 2 is negative 8. Set each factor that contains a variable equal to 0. And our solutions here should be 2 and 6. Now, let's take a look at the next example. X to the fourth minus 8x squared equals negative 12. Similar problem, except it's x to the fourth and not x squared. I still want to set the equation equal to 0, so I'm going to add 12 to both sides. Now, I know I can break down x squared as x times x. So the question now is, how do you break down x to the fourth? Well, that's x squared times x squared. Now, similar question I asked earlier, factors of 12 that add up to be negative 8. Well, thanks to the previous problem, that's negative 6 and negative 2. Now again, the negative 8x squared is not gone anywhere because we have here negative 2x squared minus 6x squared. Okay. Set each factor that contains a variable equal to 0. Remember, plus or minus when you take the square root property. So now I have 4 solutions, plus or minus the square root of 6, and plus or minus the square root of 2. Again, notice the degree of this problem is 4, and we have 4 solutions. Here we had a degree of 2, and we have 2 solutions. All right, now let's go down here then and take a look at x plus 3 squared plus 6 times quantity x plus 3 plus 8 is equal to 0. So again, the question then is going to be, how do I break down x plus 3 squared? Well, that is going to be x plus 3 times x plus 3. So I'll write that in blue. Because x plus 3 times x plus 3 is x plus 3 squared. So now I need to know factors of 8 that add up to be a positive 6. Well, that's going to be 4 and 2. 4 times 2 is 8, and 4 plus 2 is 6. Now, somebody is asking me, where is the 6 times quantity x plus 3? Hasn't gone anywhere. That's this plus this. Okay, now let's go back to the factored for a minute. See this? 3 plus 4, that's 7. 3 plus 2, 5. And now I can solve each of these. Set each one equal to 0. Okay. So my 2 solutions are negative 7 and negative 5. Now, let's take a look at 2x to the fourth plus 7x squared plus 6 is equal to 0. So again, remember, now this problem is different because the leading coefficient is not 1. So we're going to do the factor by grouping method. If you recall, I'm going to take 2 times 6, so that's factors of 12, whose sum is a positive 7. That's 4 and 3. 4 times 3 is 7. I'm sorry, 4 times 3 is 12. And 4 plus 3 is 7. So now I'm going to rewrite this is 2x to the fourth plus 4x squared plus 3x squared plus 6 equal to 0. Now, how many terms do you have on the left-hand side now? You have 4. The only factoring technique that we can use here is factor by grouping. So I'm going to group the first 2 terms and the last 2 terms together. The GCF from the first 2 terms is 2x squared. When I factor out or divide that out, I'm left with x squared plus 2. From the last 2 terms, I can factor out or divide out a 3, leaving me with x squared plus 2. Now, notice what this and this have in common. Both of them have x squared plus 2. And I'm left with 2x squared plus 3. Again, you can always check this by foiling it and getting back to 2x to the fourth plus 7x squared plus 6. Set each factor that contains a variable equal to 0. Now remember, with the negative under the square root, I'm going to take out an imaginary unit of I. And I will write it as square root of 2 times I. Okay, set the other factor equal to 0. Square root. Now, there is going to be some work that I need to do here. Okay, so I will do this here. I will rewrite them as 2 separate radicals. I will pull out the imaginary unit of I. Now, I want to rationalize the denominator, meaning to get rid of the radicals in the denominator. So I'm going to multiply the top and the bottom by the square root of 2. Remember, when I do that, I'm multiplying by 1, and when I multiply by 1, nothing changes. So I have 4 solutions here, plus or minus the square root of 2i, and plus or minus the square root of 6i divided by 2. Now, let's take a minute here and identify how I knew these were going to be factorable. Let's start with the very first example. Again, squared and x to the first. This number is twice as big as this number. That gives me an indication I can factor. This exponent power 4 is twice as large as this exponent power, which is 2. I know I can factor. This exponent power 2 is twice as big as this one. Since there's no number there, we assume it's 1. This is twice as big as this. I can do that. Okay. So if the one exponent is twice as large as the other one, I should be able to factor this. Okay, let's do the last 2 examples then. Again, notice x to the 2/5 is twice as big as 1/5 because 1/5 times 2 is 2/5. So how do I break down x to the 2/5? Well, that's going to be x to the 1/5 and x to the 1/5. And x to the 1/5 times x to the 1/5 is the same thing as x to the 1/5 plus 1/5 power, which is 2/5. Okay, now the other part is factors of 12 whose sum is 7. That is a positive 3 and a positive 4. Now again, the 7x to the 1/5 hasn't gone anywhere. There's 4x to the 1/5 plus 3x to the 1/5. Okay, set each factor that contains a variable equal to 0. Now remember, to get rid of this, I'm going to take both sides to the 5th power. So I'll do this in blue so we can see to the 5th and to the 5th. Okay, negative 3 to the 5th power is negative 243. All right, let's do the other factor. So again, I'm going to take both sides to the fifth power because it's x to the 1/5. And negative 4 taken to the fifth power is negative 1,024. Again, I would always suggest in this section to check your answers to make sure they work. They both work here. Okay, one other example I want to take a look at then. We have x minus x to the 1/2 power minus 6 is equal to 0. 1 is twice as big as a half because 2 times 1/2 is 1. It means I can factor. So how do I break down x? That will be x to the 1/2 times x to the 1/2. Now, I need to ask myself, factors of negative 6 that add up to be negative 1. Well, that's negative 3 and a positive 2. Okay, set each factor that contains a variable equal to 0. Now, in the last problem, it was x to the 1/5, and I took both sides to the fifth power. Because it's to the 1/2, I am going to square both sides and get x equal to 9. If it was x to the 1/4, I would take both sides to the fourth power. Now, the problem is here. Now remember what x to the 1/2 represents. That's the same thing as a square root of x. There is no way a square root equals a negative number. Okay? So I know right here this is not going to be a solution. Okay? Now I will finish it. X equal to 4, and when you go back and plug in 4, that's 4 minus 4 to the 1/2 is 2. 4 minus 2 is 2. 2 minus 6 does not equal 0. That is not going to be a solution. So here my only solution is x equal to 9. So again, it is very important to check all of your answers to make sure that they work with these problems.